All right, let's talk about one of the most epic ideas humanity has ever dreamed up. And I mean, we're not just talking about building a new city or a faster rocket, we're talking about building something around an entire star.
I mean, really let that sink in for a moment. Every single photon, every watt of energy that our sun pours out into the emptiness of space, what if we could capture all of it for ourselves? It's a concept that pretty much stretches the limits of what we can even imagine.
So, is this just some cool idea for a science fiction movie? Or is there an actual blueprint? That's the big question we're going to dig into.
And our story really begins back in 1960 with this absolutely brilliant physicist, Freeman Dyson. He looked up at the stars and saw something more than just giant balls of burning gas. He saw the ultimate power source. So, what he proposed is the Dyson sphere. At its heart, it's a theoretical megastructure with one single, incredibly ambitious job to completely surround a star and drink up its energy. Now, right away, let's clear up the biggest misconception. When you hear Dyson sphere, you probably imagine a massive, rigid, Death Star-like shell, right? Well, that's not what Dyson had in mind at all. His original idea was actually way more practical and elegant. A gigantic orbiting cloud of independent solar collecting satellites. But why on earth would we ever need to do something so extreme? The answer is pretty straightforward. Our civilization is going to need an almost unimaginable amount of energy to keep growing. Just try to wrap your head around that number. That's 380 followed by 24 zeros. That's the amount of power our sun unleashes every single second. To put that in perspective, in 1 second, the sun puts out more energy than humanity has used in our entire history. And right now, pretty much all of it just radiates away into space, totally wasted. This whole idea plugs into this fascinating framework called the Kardashev scale. It's a way of classifying advanced civilizations not by their culture, but by how much energy they can control. A Type 1 civilization has harnessed all the energy on its planet. A Type 2 has harnessed its star. And a Type 3, well, they've harnessed their entire galaxy. And this shows us exactly where we are on that cosmic ladder. We're not even a Type 1 civilization yet. We're currently sitting at about a zero point 0.7. Building a Dyson sphere is basically the graduation project for becoming a Type 2 civilization. And as you can see, that is a massive, massive leap. So if we were actually going to build one of these, what would it look like? Turns out, there are a few different models to choose from. The options pretty much boil down to two main camps. On one side, you've got the Dyson swarm. It's stable, you can build it piece by piece over centuries, and it's actually physically possible. On the other side, you have that solid shell from the movies. It's cool, but it would be gravitationally unstable and require physics-breaking materials. So pretty much all serious scientists agree, the swarm is the only way to go. So, we know the what and the why. But it's the how where things just get completely mind-boggling. This would be, and I am not exaggerating, the single greatest engineering project in all of human history. I mean, just think about it for a second. To build a cloud of satellites so big that it can actually block out a meaningful amount of sunlight, where do you get all that stuff? Earth doesn't have anywhere near enough raw material. The answer is kind of brutal, but also brutally efficient. To get that much material, we'd probably have to completely dismantle an entire planet. And Mercury is the perfect candidate. It's basically a giant ball of metal, it's already sitting right next to the sun where we need it, and it has low gravity, which makes launching all those pieces so much easier. The leading theory is that we'd send an army of self-replicating robots to just mine the whole planet down to its core, turning it piece by piece into our solar collectors. And just getting the material is only the first problem. You'd have to deal with just an incredible amount of waste heat radiating off the collectors. You'd need to coordinate the orbits of maybe billions of satellites so they don't all smash into each other. You'd have to figure out a way to beam all that power back to where we can use it. And maybe the biggest pill to swallow, you'd be starting a project that could take thousands of years to complete. So let's just pull back for a second. This isn't just a crazy thought experiment about our own future. It also gives us a potential signpost to look for out there in the galaxy. See, a star that's surrounded by a swarm of collectors would look really weird to our telescopes. Its normal visible light would be dimmed, but it would also glow unnaturally bright in infrared light because of all that waste heat. And astronomers are actively searching the skies for exactly that kind of strange signal. A few years ago, we actually thought we might have found one.
There was this star, nicknamed Tabby Star, that was dimming in ways that nothing could really explain. It led to some serious speculation about an alien megastructure. Now, it later turned out to most likely be a massive cloud of dust, but the whole experience proved that we're really truly looking.
And that really brings us to the final, most important thought here. A Dyson sphere is more than just an engineering project. It's a symbol of a species that has truly secured its own future. The physics are possible. The engineering is at least imaginable. So the real question isn't about our technical skills, it's about our wisdom. Will we solve our problems here on Earth and learn to work together long enough to even get the chance to try?